Hello and welcome to G Fun Facts Online. When you think of a drought, what comes to mind? Probably a cracked, dry landscape under a scorching sun, a place that hasn't seen rain for months, or even years. For a long time, that's how we've all understood drought, a simple lack of rain, a supply problem. But what if I told you there's another, more powerful force at play? A hidden driver that's making droughts worse all over the world, even in places where the rainfall hasn't changed much at all. Today, we're talking about the Earth's thirsty atmosphere. Imagine the air around us is a giant, invisible sponge. As our planet warms, that sponge is getting bigger and thirstier, pulling precious water from our soil, our rivers, and our plants faster than ever before. This phenomenon has a scientific name, atmospheric evaporative demand, or AED. Think of it as the atmosphere's appetite for water. The thirstier the atmosphere, the faster water disappears from the surface. So what makes the atmosphere thirsty? It's a combination of four key things. First, temperature. Warmer air can hold more moisture. It's a basic law of physics. For every single degree Celsius of warming, the air can hold about 7% more water vapor. Second is humidity. When the air is dry, it's like a dry sponge. It soaks up water much more quickly. Third is solar radiation. The sun's energy is the engine that powers the whole process, turning liquid water into vapor. And finally, there's wind. Wind whisks away the moist air right above the surface and replaces it with drier air, ready to soak up even more water. When you have high temperatures, low humidity, clear sunny skies, and brisk winds, the atmosphere's thirst is at its absolute peak. Now, here's the critical part. This isn't just a natural cycle. Our changing climate, fueled by the burning of fossil fuels, has put this atmospheric thirst into overdrive. As global temperatures climb, the atmosphere's desire for water increases relentlessly, and the impact is staggering. Groundbreaking research has found that since 1981, this rising atmospheric thirst has made global droughts, on average, 40% more severe. Before then, drought trends were mostly stable. We have officially entered a new era, where rising temperatures are the main character in the story of drought, and lack of rainfall is sometimes just a supporting actor. Let me give you an analogy to make this really clear. Think of your personal finances. Rainfall is your income. The atmosphere's thirst, or evaporative demand, is your spending. Now, even if your income stays exactly the same, what happens if your spending suddenly goes way up? You fall into debt. It's the same with our planet's water. Even if a region gets its normal amount of rain, a thirstier atmosphere can plunge it into drought by simply taking out more water than is coming in. This has a number of dangerous effects. First, it accelerates drying. Landscapes dry out much faster, stressing plants and depleting the moisture in the soil. Second, it makes it harder for the land to recover. Even if a drought is followed by a wet year, the super thirsty atmosphere can whisk that new moisture away before it has a chance to soak in and replenish the groundwater. This can lead to a long-term, perhaps even permanent, decline in soil moisture as the planet continues to warm. And this problem isn't just making dry places drier. It's expanding the reach of drought. Between 2018 and 2022, the global land area affected by drought grew by an average of 74% compared to the previous decades. And get this, increased atmospheric thirst was responsible for 58% of that expansion. In 2022 alone, a record 30% of the Earth's entire land surface was hit by drought, and nearly half of that was attributed directly to this increased thirst. The consequences are felt by all of us. It means less water in our streams, our aquifers, and our reservoirs, which directly impacts the water available for us to drink and for our industries. It also creates a massive wildfire risk. As the atmosphere sucks the life out of plants and trees, they become tinder-dry fuel. The devastating California wildfires in 2020 and 2021, for example, happened during years of exceptionally high evaporative demand. And of course, it's a huge threat to our food supply. A thirsty atmosphere stresses crops, reduces harvests, and disrupts entire ecosystems. So what do? It's clear that our old way of thinking is no longer enough. We can't just monitor rainfall and hope for the best. We have to shift our focus and start tracking the demand side of the equation. Scientists have already developed tools to do this, like the Evaporative Demand Drought Index, or EDDI. This tool acts as an early warning system by tracking how unusually thirsty the atmosphere is in a specific place. It can help us spot rapidly developing flash droughts and give earlier warnings to farmers, fire managers, and city planners. Adapting to this new reality means we also need new strategies. We need to think about how to reduce the water loss itself. This could mean planting more drought-resistant crops, using hyper-efficient irrigation systems, and promoting farming practices that help the soil hold on to its moisture. As our planet warms, the atmosphere's thirst will only grow, fundamentally changing how water moves around our world. Understanding this hidden driver of drought is no longer just a fascinating piece of science. It is absolutely essential for building a resilient future on a hotter, drier planet. Thanks for listening to Fun Facts Online.